Yeah. So what we discussed in the previous class, we discussed about the Docker, SAM, everything, right? And I show you the Kubernetes, what is Kubernetes, what is, right? Yeah. What is a Kubernetes, guys? What is a Kubernetes? Kubernetes is a orchestration platform. Kubernetes is the orchestration platform, guys. So what it will manage? To manage the, what it will manage, guys? To manage the,
Containers.
yes. Who developed this, guys? Initially, who developed the Kubernetes?
Google.
Yes. Developed by Google using which language? Go language. Okay. So Google is donated to, guys. Google donated Kubernetes to,
CNCF.
yes, very donated to CNCF. CNCF is nothing but a cloud native and cloud formation. Okay. K8 is first version released in 2015. K8 is first version released in 2015. When it was released, guys? 2000. So 15 means 10 years completed, right? It is free and open source. It is free and open source. Guys, understood? Not Kubernetes will use Docker internally. Using Kubernetes, we will manage our Docker containers. Our guys understood? So what is Kubernetes? Kubernetes is a orchestration platform to manage the containers developed by Google using Go language. Google donated Kubernetes to CNCF. Kubernetes first version released in 2015, and it's a free and it is free and open source. Kubernetes will use the Docker internally. Using Kubernetes, we will manage our Docker containers. So what is that, guys? So we will use the Kubernetes to manage the Docker containers. Understood, guys? What is that? So Docker, some versus Kubernetes. What is this, guys? We already discussed it, right? Docker Swarm Docker Swarm does not have auto scaling. Docker Swarm does not have auto scaling capability. Scaling is manual process. Scaling is manual process. Kubernetes supports auto scaling. supports auto scaling. Auto scaling. For the production deployment, Kubernetes is highly recommended. So for production, for production deployments, for production deployments, Kubernetes is highly recommended. Right? Kubernetes highly recommended. Kubernetes is replacement for Docker Swarm. What is that, guys? Kubernetes is replacement for the Docker scam.
Bro,
Auto.
bro,
Uh,
you continue. I will be back in 2 minutes.
okay. So auto scale. Increasing and decreasing. Increasing and decreasing containers count based on the based on the incoming request. Based on the incoming request for our based on the incoming request for our for auto scaling. What is that, guys? So, what is a cluster? What is a cluster? Kubernetes cluster. What is a cluster? What is a cluster? Guys, what is a cluster? So, cluster is nothing but a group of servers or group of nodes. Group of nodes means servers or VMs. Okay. Master nodes. Master nodes. Worker nodes. Worker nodes. DevOps engineer or developer will give task to Kubernetes master node. Kubernetes master node. What is that, guys? So master node will manage the worker nodes. Master node will manage worker nodes. Master node will schedule task to worker node. Tasks to worker node. So master node will schedule the task to the worker nodes. Okay. Our containers will be created in worker nodes. Where the containers will be created? The containers, our containers will be created on worker node. Our containers will be created on worker nodes. Using cluster, we can achieve high availability. What is that, guys? Cluster, we can achieve high achieve high availability. We can achieve high availability. Guys, understood? So, what is Kubernetes? What is Docker Swarm versus Kubernetes? What is a cluster? Group of nodes, master node, worker node, DevOps engineer, developer will give the task to the master node. Master node will manage the worker nodes. Master node will schedule the task to the worker nodes, and our containers will be created on worker nodes using cluster. So we can achieve the high availability. We can achieve the high availability. So what is the Kubernetes architecture? What is the Kubernetes architecture? So what is the Kubernetes architecture, guys? So a Kubernetes architecture contains what it contains. I already told you, right? Control plane, master node, or manager node. Control plane, master node, manager node. Okay. So this control plane contains API, API server. So second one is scheduler. Second one is scheduler. Third one is control manager. Control manager. Fourth one is HCD. Fourth one is HCD. I will tell you guys all these what these four worker nodes. This is the so the above are the master node components and the worker node are nodes. We have a worker node or worker nodes. What it contains the pods, container, kubelet, kubeproxy, Docker, runtime. Guys, understood? So Kubernetes architecture, control plane, master node, and manager node, API server, scheduler, controller manager, etcd, in the worker nodes, pods, container, kubelet, kubeproxy, and the Docker runtime. I will tell you guys. I will tell you the architecture. How to communicate? How to communicate with the Kubernetes control plane? How to communicate with the Kubernetes control plane? How you can communicate, guys? You can communicate by using kubectl is the CLI tool, and the other one is web UI dashboard. Open lens. You can use the open lens. Guys, understood? You can use the how to communicate with Kubernetes control plane. You can use the kubectl, web UI dashboard. Okay, how to communicate with the Kubernetes control plane. Okay, yeah. Now I will show you. Yeah. So this is the Kubernetes architecture. What this is, guys? This is the Kubernetes architecture. So this is the control plane. A control plane contains API server. A control plane contains API server, scheduler, control manager, and HCD. So what these four? So who will manage these worker nodes? Worker nodes will managed by the master node or a control plane. So something like a Kubernetes. What is a Kubernetes architecture? So we can manage our Kubernetes. We can manage our Kubernetes. We will manage this. It's a orchestration platform to manage the containers. To manage the containers. So what it contains the group of nodes, master node. Master node is nothing but a control plane and worker nodes. So DevOps engineer or developer will give the task to the Kubernetes master node. So we'll give the task to the master node. Master node will manage the worker nodes. What is this, guys? The master node will manage the this master node will manage the worker nodes. Yeah. So what this, guys? So this is the So this is the cluster. A cluster contains the master node. So master node and the worker node 1, worker node 2. Your application is deployed on the where your application is deployed on the worker nodes. Your application is deployed on the worker node. Who will manage these worker nodes? So the master node will manage the worker nodes. Who will manage, guys? So the master node will manage the worker nodes. Master node will manage the worker nodes. So how we can communicate with this control plane? So you can create a remote server or something like your Windows machine. What is that? Your Windows machine, your Windows machine or something like a remote server. Or something like a remote server. So how you can interact with this control plane? You can interact with this control plane through remote server or something like a Windows machine. So in Windows machine, what software you need to download? You need to download the Open Open Lens. So Open Lens is the software to communicate with the control plane and the worker nodes. To communicate with the worker nodes and the master node. So this is the open lines. You can use the open lines to communicate with the master node. Okay, or else you can use the this is the remote server. Sorry. So this is this. This is your remote server. This is your Windows machine. Okay, you can use the kubectl command. This is the kubectl command to interact with the control plane. Okay. So for example, so if you want to give instructions to the master node from the Kubernetes, so this is the manifest file, something like this is a pod.aml file. For example, guys, for example, I want to create a container in the worker node. So this pod.aml, right? Kubectl -f apply file name pod.aml. Okay. So whatever we mentioned in this, right? So it will communicate with the Kubernetes. It will communicate with the Kubernetes control plane. So this will taken care by this request will be taken care by the API server. API server will send the information to the HCD. HCD is the a storage. So where are the files will be stored under the HCD? Something like it's like a database. So once it is copied into the kubectl, right? Then it will check the it will inform to the scheduler. Scheduler will tell to the control manager. Control manager will talk to the kubelet. So in the kubelet, it will verify where the space is available to deploy a container. For example, worker node one, there is no space. So it will communicate with the worker node two and will create the container in the worker node two. Guys, understood? What is pod? So pod is a new name in the Kubernetes, right? The containers. What is a container? Container, you know. So within the pod, there is a containers. Why pod? What is a pod? Why the pod containers are within the pods, right? The kubelet is the agent. What is this? This is the agent. It will verify the health checks if the container is running or not, if the pod is running or not, if inside the pod there is a containers are running or not. So we will validate the kubelet is the agent. It will validate the health check the containers. So if it is down, kubelet will inform to the API server. API server will check that in the HCD, how many containers we need to run on this server service, something like the minimum replica set is something like a one. It will automatically start the container. Something like if the pod, so based on the traffic, we need to increase the container. We need to increase the containers or we need to increase the pod. So a pod contains a container, right? Maximum you guys can remember. So maximum a pod contains a one container or a pod contains the multiple containers. Okay, mostly they created as a one container. Okay, so yeah, so this is nothing but a Kubernetes architecture. I will show you again in the So to communicate with the Kubernetes cluster, we have two options. So it is user interface and kubectl. Master node manages the worker node in the cluster. It will assign tasks to the worker node for the execution. Worker node will run the tasks which are assigned by the master node. So yeah, here you see guys. What is kubectl is the command mode in order to perform the operations on the master node. In order to perform the masters on the master node. So if you run the kubectl command on the master node, API server will execute. Execute a command by kubectl that will talk to the API server. API server will act as a mediator between Kubernetes kubectl and the Kubernetes software. So API server will talk to the so execute a command by the kubectl that will talk to the API server and API server will act as a mediator between kubectl and Kubernetes software. Whenever a request comes from the kubectl, that will be taken care by the API server and will talk to the underlying Kubernetes software. So this taken care by the API server and will talk to the underlying Kubernetes software. Whenever a request comes from API server, an API server stores the information in the HCD. It will store it in the HCD. HCD is a data store in the Kubernetes and it will act as a database to store the details on the Kubernetes cluster. So scheduler is going to check that what are the pending tasks are available. Then scheduler is going to assign the task to the control manager. Okay, so it's stored in the HCD, right? The scheduler is going to check that what are the pending tasks are available in the scheduler. Is going to assign a task to the control manager. Control manager is going to schedule them before going to schedule. Scheduler will talk to the kubelet. Scheduler will talk to the kubelet. So so scheduler will talk to the scheduler will talk to the kubelet. Kubelet is a worker node agent. What is this? Kubelet is a worker node agent. Kubelet is a worker node agent. It is going to check the health of the node. It is going to check the health of the node. Kubelet will check the resources available in the node. Kubelet will check the resources available in the node. So kubelet will make sure pods are running successfully and containers are running successfully. Right? Kubelet will make sure, kubelet will check resources are available in the node. Kubelet will make sure the pods are running successfully and the containers are running successfully. Kubelet will create a containers. Kubelet will create a containers on the worker node using the pods with the help of Docker runtime. With the help of Docker runtime. So Docker runtime is we are using to create a containers. This is the service to run the service. So we want to create a run the Docker containers. Definitely we need to use the Docker runtime. So we are using to create a container. We are using to create a containers. Okay, kubelet will create a containers worker node using the pods with the help of Docker runtime. Docker runtime is we are using to create a containers. Container is nothing but a runtime of our application. So runtime of our application. Guys, understood Kubernetes cluster? Guys, guys understood? Satish, Prem, Meghna,
Yeah, bro. Yeah.
understood? Huh? Yeah. In the master node,
Yeah.
what are the components, guys?
API server, scheduler,
Hmm.
controller manager, etc.
Hmm. What is HCD? HCD.
Is a data store to store the details of the cluster.
Yes. What is API server? API server is the main. So, so it will communicate from the kubectl or OpenLens, whatever it may be. So first it will talk to the API server. API server will talk to the Kubernetes software and it is stored in the HCD. The information will be stored in the HCD and scheduler. Then scheduler will active. Scheduler will check it. Is there any pending task? So that will be informed to the controller manager. Controller manager will schedule it. And the kubelet will talk to the that API server. Kubelet will talk to the API server. If there any is container, something like the health of the nodes, health of the pods, health of the containers will be taken care by the kubelet. What is a kube proxy? So the network part. The network part will be taken care by the kube proxy. The network, right? We need a network to communicate with these two pods or something like. So for that we use the kube proxy is the network service. Guys, understood? So this is most important, guys. Everyone in the interviews, they are asking what is the Kubernetes architecture. So Kubernetes architecture contains the master node and worker nodes. It's a Kubernetes cluster. A cluster is nothing but a group of nodes. One master node or a number of master nodes also we can use it. A master node with a worker node. So worker node contains the pods, containers, kubelet, kubeproxy. Docker runtime. And the master node or a control plane contains a worker node is nothing but a data node, data plane also. We call it as a data plane. A worker node is nothing but a data plane. Master node is nothing but a control plane. Okay. So a worker node contains the pod, containers, Docker, kubelet, kubeproxy. So a master node contains the API server, scheduler, controller, and etcd. Guys, understood? Is it easy? Guys, easy, easy, easy. Yeah.
Yes, bro.
What is
Yeah.
that?
Yeah.
Hmm? Is in the Meghna, Satish, Shri. Yeah. So control plane, master node or a manager node. So what it contains? It contains the components called as a API server, scheduler, control manager, and etcd. So worker nodes. What are the worker nodes? A pod, container, kubelet, kubeproxy, Docker runtime. So you know container and you know kubelet. Kubelet is the worker node agent. So it will come. It will talk to the master node and worker node. And kubeproxy is the networking. What is a pod, guys? So what is a pod? We'll discuss. So how to communicate with the Kubernetes control plane? We can use the kubectl and web UI dashboard. So the open lines. So through the open lines also we can communicate it. Guys, understood? Yeah. Kubernetes architecture. What are the Kubernetes architecture components? The Kubernetes architecture components are control plane, Control plane. What is the control plane? Control plane is called as master node. Control plane is called as master node, responsible to handle Kubernetes related work. Control plane is a control plane is called as a master node, responsible to handle the Kubernetes related work. Okay. So what is the worker node? So worker nodes. What is worker nodes? Is responsible to execute our applications as a parts. Application control plane is called as a master node responsible to handle Kubernetes related work. Worker node responsible to execute our applications as parts. Responsible to execute our applications as parts. Right. What is that? The next one is controller. What is the first one, guys? First one we'll discuss API server. What is the first one? First one is API.
API server.
What API server, guys? It is responsible to handle incoming request of control plane to deploy our application. Right? It is it is responsible to handle incoming requests of control plane. Control plane to deploy our applications. To deploy our applications. So what is the next, guys? Next is HCD. What is HCD, guys? HCD. What is HCD? It is an internal database in Kubernetes cluster. API server will store requests or tasks info in HCD, right? It is an internal database in Kubernetes cluster. Guys, what is K8s? You already know, na? What is K8s? K8s is nothing but a Kubernetes. Guys, so in between K and S, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. Right? That's the reason K8s. K8s is nothing but a Kubernetes cluster. Kubernetes cluster. API server will store requests or something like a tasks info in HCD. Task info in HCD. What is the next one is scheduler. What is that? Scheduler. What scheduler is doing, guys? It is responsible to schedule pending tasks available in HCD. It will decide in which worker node our task should execute. Scheduler will decide that. Scheduler will decide that by communicating with the kubelet. Communicating with the kubelet. Guys, understood? Scheduler. It is responsible to schedule pending tasks available in HCD. Available in HCD. It will decide in which worker node our task should execute. Should execute. It is responsible to schedule pending tasks available in HCD. It will decide in which worker node our task should be execute. Our task would be execute, and scheduler will decide. Scheduler will decide that by communicating with kubelet with the kubelet. You guys understood? So this is nothing but a scheduler. So the next one is kubelet. What is kubelet, guys? It is a worker node agent. What it is? It is a worker node agent. It will maintain all the information related to worker node. So it is a worker node agent. It is a worker node agent. It will maintain all the information all the information related to worker node. Worker node. Kubelet, it is a worker node agent. It will maintain all the information related to a worker node. Okay, the pods are healthy or not, the containers are healthy or not, something like nodes are healthy or not. So who will verify? The kubelet will verify. So will verify the health condition of the worker nodes. Health condition of the worker node. Is understood? Controller manager. So what is the controller manager? Control after scheduling. After scheduling completed, controller manager will manage our task execution in worker node. After scheduling completed, controller controller manager will manage our task execution in worker node, or task execution in the worker node. So what is a queue proxy? Yes, what is a queue proxy? Queue proxy, it will provide network for Kubernetes cluster communication, master node and worker node. What is that? Cube Queue proxy. It will provide network for Kubernetes cluster communication. It will provide network for Kubernetes communication, Kubernetes cluster communication. So what is this? How you can communicate a master node, worker node? Queue proxy, it will provide a network for the Kubernetes cluster communication. What is that? Queue proxy. So it will provide a network for Kubernetes cluster communication. Controller manager. After scheduling completed, controller manager will manage our task execution with worker node. Yes, now you understood? Queue proxy. So what is that? Docker engine. So the next one is Docker engine or Docker runtime. Docker engine. Docker engine need to run. If the Docker service is not running on the worker node, it will not, the Kubernetes will not work. Okay. Because of, if you want to, if the pod crashes or container crashes, who will create that? The Docker engine. With the help of Docker engine, Kubernetes will create it, right? If the Docker engine is not, Docker service is not running, so the containers will not run. To run our containers, Docker engine is required. Docker engine is required. Containers will be created in worker node. In worker node. What is a container? So what is a container, guys? It is a runtime instance. It is a runtime instance of our application. It is a runtime instance. It is a runtime instance of our application. Our application. What is pod, guys? What is a pod? Inside the pod, the containers are available, right? What is a pod? It is a smallest building block. It is the smallest building block that we will create in Kubernetes to run our containers. So what is a pod? It is a smallest building block. It is a smallest building block that we will create in Kubernetes to run our containers. It is the smallest building block that we will create in Kubernetes to run our container. Okay. So note, guys. What is the note? Note is nothing but a Docker containers will run inside the pod. Inside the pod. So Docker containers will run inside the pod. Inside the pod. Pod is the smallest building block that we will create in Kubernetes to run our containers. Set smallest building block. It's a logic block. It's not a so it's a building block. Smallest building block we will create in Kubernetes to run our container applications. So Docker containers we will run inside the pod. Is understood? Next is Kubernetes cluster setup. What is this, guys? Kubernetes cluster setup. So how you can set up the Kubernetes? How we can set up the Kubernetes? We can set up the Kubernetes in two ways. One is self-managed cluster. We will create our own clusters, guys. So we will create self-managed means we will create our own clusters. What is that? The first one is a mini cube single node cluster. Single node cluster. Next one is so master node and worker node contains in so within the node that node is nothing but that cluster is nothing but a mini cube. Mini cube is nothing but a, only one instance. In that one instance, it will create the worker node and the master node. That is nothing but a mini cube. The second one, cube ADM. So cube ADM is nothing but a cube ADM is nothing but a multi-node cluster. What is that? Cube ADM is nothing but a multi-node cluster. This is the one. So this is the one is a yeah. So you see, so this is one node. This is a node. Here we use three nodes. So multi-node cluster we can use the cube ADM. Multi-node cluster, so we can use the cube ADM. Guys, understood? So provider managed clusters. So who are the cloud providers, guys? Guys, who are the cloud providers?
Amazon, Azure.
Azure, Google.
What is that? Ami? So Amazon company also created their own service called as a EKS. EKS? EKS means, guys, AWS? AWS EKS. Azure. Azure also created their own service called as a Azure. Azure AKS. Azure Kubernetes Service. Was GCP also. GCP have also created their own service called as a GKE. Google Kubernetes Engine. OCI, Oracle also. So they created the OKE, Oracle Kubernetes Engine. So IBM Cloud also created their own called as a IKE, IBM Kubernetes Engine. Guys, understood? So these all are the service they created as a service. If you want to use the Amazon, you can use the Amazon EKS. If you want to use the Azure, you can use the Azure EKS. So if you want to use the GCP, you can use the GKE. OCI Oracle, you can use the OKE. IBM Cloud, you can use the IKE. Guys, understood? So these all are the provider managed Kubernetes cluster. Kubernetes provider managed clusters. Cloud provider will give a mm, read mode cluster. Provider managed cluster. Provider managed cluster, something like a cloud provide will give read made cluster, ready made cluster. They will take the charges. Applies. The charges will be applied. So what are those, guys? One is AWS, EKS, Azure EKS, G. Understood? Understood, guys? Yeah. So in this course, what we will discuss, we'll discuss about the AKS installation. So tomorrow, what we will show you, I will show you AWS EKS cluster setup. AWS EKS cluster setup, and we'll discuss. So that cluster separate, and the Kubernetes components, guys. What is a pod? What is a services? What is a namespace replication controller? So, guys, The game starts from tomorrow. Okay? Be careful. Thank you, guys. We'll continue from tomorrow.